Identify slope and y-intercept. First, when we're talking about slope and y-intercept, we're talking about linear functions, and remember that's y equals mx plus b, and it just makes a straight line. So your line can either be positive, meaning it has a positive slope because it goes up from left to right, or it can have a negative slope, meaning it goes down from left to right. Slope is just a rate of change. It's the change in y over the change in x. And there's a pretty quick way that we can find the slope from a graph called rise over run. So this method requires you to find two perfect points. Here's one, and here's another one in green. And I typically like to start on the left, so the left point, and go to the right point. So you're going to count and see how many do you have to go up or down to get from one point to the other. Starting here, we'd have to go down 1, 2, 3. So since we went down 3, that makes that a negative 3 because you went down, meaning your y values changed by going down 3. So we went down 3. Now we need to know how many are we going to move to get to the other point, left or right. We're going to have to go right 1, 2, 3, 4, 5, 6, 7, 8 times. Now since we moved right, that would be a positive change in x. So we went down 3 and right 8. So for this one, your slope is negative 3 over 8. The y-intercept is really easy. It's just the point where the y-axis, which goes up and down, crosses your linear function. So that would be at this point here. So technically this is the point 0, 1, or we can just say the y-intercept is 1. Let's do an example. We need to find the slope, so we need to locate two perfect points. There's one here and there's one here. Now we're going to move up and down, left or right, to get from one point to the other. It doesn't matter which point you start with as long as you know up and down is your change in y, left and right is your change in x. So, starting just because I like to start with the left point, that's where I'm going to start. So, we are going to have to move from this point here, right 1, 2 times. So, we had to move right 2. I'm just making a note of that. Then we have to move up 1, 2, 3, 4, 5, 6, 7. So up 7. Now my change in y over change in x, I went up 7, right 2. So that rate of change would be positive 7 over positive 2, or just 7 over 2. The y-intercept is the point where this red line crosses the y-axis. That point is here. That was a negative 2 on the y-axis, so the y-intercept is negative 2. And the equation that we're going to write is in slope-intercept form. Y equals mx plus b. The only two things we have to change about y equals mx plus b is we're going to replace the m with the rate of change or the slope, and then plus b is going to be plus or minus whatever the y-intercept was. So we have y equals 7/2 was our rate of change, x, and negative 2 was the y-intercept. And that's how you write an equation from a graph, finding the slope and the y-intercept. Now let's do an example of kind of a word problem or a description of a linear function. The basic shipping charge is $10 for the item via USPS and $7 more for each additional item. So what you're looking for is the slope, and your slope is going to be the rate of change. So rate of change is often told to us by the words per, each, or every. Those are some commonly used words to tell you a rate of change. So in this one, we see that it's $7 more for each additional item. So that denotes a rate of change. The rate of change is it goes up by $7. Then the Y-intercept is usually a flat fee or a registration fee, but anytime you see that word fee, that typically is the rate of change or the Y-intercept. And another phrase that's often used is initial value. Okay, so here the basic shipping charge would be that flat fee. So that flat fee is $10. So that's our Y-intercept. And the equation, we just plug in slope and Y-intercept. Y equals, the rate of change was 7x, and we had a positive 10, so that's going to be plus 10 for the Y-intercept on the end.